So for those of you who have worked with me on these kind of questions before, Kandyce and I are each going to do one question. The first way we're going to do this on the amortization chart is that we're going to talk about what to do with the chart if they give you the payment amount and they want you to find the loan amount. Then Kandyce is going to do what to do if they give you the loan amount and they ask you to find the payment. So they're going to kind of flip the script. Maybe they could go two directions with this thing. So let's start here with this one. We're going to walk it through slowly. But then, because we each have a different way of explaining it, hopefully one of our ways or both of our ways will help it click for you. So when you get, what I always tell people, when you get in that testing center and you see the chart, whether it's on the desk, whether it's on the wall, whether it's something they handed you, whether it's in the question itself, every testing center, I've heard all different ways they do this. And I told a funny story one time. I went and took the Alabama state law portion only, and they handed me an amortization chart just in case I wanted one. And I'm like, I'm not even going to do math. I'm not doing the national today. I'm only here for Alabama. And they're like, doesn't matter. Everybody gets the chart. So you're going to get this chart. Now, here's what you're going to do. The first thing I want you to do is zero in on this chart at what the chart's telling me. So if you look at your screen here at the chart, it says the monthly payment per $1,000 on a fixed rate, fully amortized loan. Let me repeat that. The monthly payment per $1,000 on a fixed rate, fully amortized loan. That's what this chart is talking to me about. So I know, because our brains want to just look at these numbers and ignore what it's telling us. That's what my chart tells me. So when I go and I ask myself the question, I say, okay, the question says, Kathy makes payments of $950 per month, which includes 5% interest rate on a fixed rate, fully amortized 30-year loan. What was the initial amount of her loan amount? Okay, what was the initial amount of her loan? So the first thing I'm going to do is going to go to my little chart, and I'm going to find 5% interest rate on the left-hand side there. So let me give you guys a couple seconds to look at this chart. Does everybody see 5% on the left-hand side for the interest rate? We know that's Kathy's interest rate. If you see it, if you feel it, if you know it, put it in the chat here. Let us know you're with us so far. You found 5% on the chart. Yes, yes. All right, awesome. Now, go across your screen there, and we're going to go all the way over till we get to the 30-year term, because we know that Kathy has a 30-year loan because they told us in the question. And it says 5.369. Y'all see that? 5.369. Everybody's got that? That number from the chart is what's going to help us solve this problem. Now, it is literal money. It is the monthly payment for every $1,000 that Kathy borrowed. She pays back $5.36.9 a month for every $1,000 that she borrowed. So let that sink in a minute. For every $1,000 of her loan, she has to pay back a monthly payment of $5.36 and some change there. Okay? So visualize that. So here we know that Kathy makes payments of $950 per month. Now, in your mind, envision, like in front of me on this table, I've got a bunch of piles of $5.36.9 all over on this table, right? How many of those piles do I have to hand you to pay you $950, to pay you $950, right? How many times do I have to pick up that pile and hand it to you? And every time I pick up a pile of $5.36 and hand it to you, that represents another $1,000 that we borrowed. So think of it like this. If her payment's $950, how many times does 5.369 go in to $950? And I want you guys to work along, so I'm not going to click the answer here yet. Put $950, that's Kathy's payment, and divide it by the number from the chart, 5.369. And tell me what y'all got. Tell me what you got. We'll give them a second here. Kandyce, sing a little song or something. I'm just kidding.
I'm singing along in the song in my head.
Do, 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 do. All right. Yes. 176.94. 176.94. Now, let me tell you something about this 176.94. That is how many times she has to hand over $5.36.9 a month. And every time she does it, like I just got through saying, all 176 times represents another $1,000 that she borrowed. So she borrowed $1,000 176.94 times, right? So if we take that 176.94 and multiply it by $1,000, her loan amount was $176,941.70. All right, that was a lot. Did it really quick. But do you guys
did.
feel like you understand what we did there? Kind of give me some feedback? Yeah? Cool.
Yay.
This is not hard unless you've never seen it before. If you go in there and they just hand you a chart and say, "Here's a math question," it's really overwhelming. But when we break it down in advance, when you go in there, you can tackle this question really easily because you've seen us do it now. Yeah, it's much easier that way. So we're going to explain it one more time because a couple people asked me to, but I'm going to go through it fast and furious so Candace can do her side of it. So what we do is we get our question. We say Kathy makes payments of $950 per month. That includes 5% interest on a fixed rate, fully amortized 30-year loan. What was the initial amount of her loan? Now, we know that the chart tells us the monthly payment per $1,000 on a fixed rate, fully amortized loan. So, what we're trying to figure out is how many thousands of dollars. So, what we're going to do is we're going to go to the chart. We're going to find our 5% because it tells us in the question that's what her interest rate is. We're going to follow it on over to the 30 years. We're going to go down and see it's 5.369. $5.36.9 is how much Kathy has to pay back per month for every $1,000 that she borrowed. We know that her payment every month, her total payment she's got to pay every month is $950. So, how many units of 5.369 is in 950? We do 950, the payment, divided by the number from the chart, and we figure out that she pays $5.36.9 every month for every $1,000 that she pays. I'm sorry, I got off track there. I was looking at the chat. So 176 times a month, she pays 5.369, rounding a little bit. So we do that number and we say, okay, every time she pays that $5.36.9, that's going for another $1,000 that she borrowed. So let's see if we take this number times $1,000, we get her loan amount, which is $176,941.70. Boom. There we go. There we go. And if you guys still feel like you need to go back over this again, we're going to send you the video. Okay. So don't worry. We're going to send you a copy of the video. We're on a YouTube link, but I just want to give time to let's now go. That's question number 1 of the possibilities. Now I'm going to stop sharing. I'm going to switch gears. And now Candace is going to do question possibility type number 2 that we might see with the amortization chart. And I'll be quiet.
All right. So I am going to be doing the problem where we are talking about, well, how do I know how much my monthly payment is? Because think about it, guys. As much as this is about passing a test, I want you to understand how this applies to real life. You want to buy a house. I want to buy a $5 million house, but I don't think I can afford the monthly payments. Let me change that. I can't afford the monthly payments on a $5 million house. So when you're going to buy a house, you know how much money you want to spend. This problem is talking about how does the banker know how much your mortgage payment is going to be? That is what this is about. How much it is going to is if I want to borrow $200,000, what's that payment? If I want to borrow $400,000, what's that payment? That is what this problem is talking about. And even though we're doing this for mortgages, this applies to cars or boat payments or any time you have a fully amortized loan. So when you talk about your car and you have a car payment and it's the same amount every month, this is how they do it. Except instead of having 30 years to pay it off, you have 5 years to pay it off, 7 years to pay it off. But the concept is the same. Now, Maria has already kind of mentioned it. The concept of what you're looking at in this chart really is we're going to charge you a monthly amount for every 1,000 you borrow. So I'm just going to say, we look at this problem. Kathy has borrowed $225,000 mortgage. Her loan has 5% interest on a fixed rate, fully amortized 30-year loan. What is her monthly payment? I love the first step of using this chart. That's step number 1. And you're going to use the chart and you're going to say, all right, I got 5% and it is 30 years. So I'm just going to go whoop, whoop, whoop. And we've already seen this number before, right? We've seen that it's $5.369. Now, somebody said in the chat, can you round it? I will tell you, most numbers I do round to like 2 decimal places. But when I deal with these numbers in the chart, I tend to not round them. Unless I'm in a rush, I tend to just go ahead and go out 3 decimal places. So whoever answered that, that's what you want to do. But I know that we got this number 5369. By the way, that number is also called a factor. When you see the word factor, this is a fancy word for rate of P&I payment. Factor is a fancy word of rate of P&I payment. What we found out is that you're going to pay $5.36, almost 37 cents for every $1,000 you borrow. Where do we get that number from? The chart. So knowing that number, because you got a loan at 5% for 30 years, if you borrowed $1,000 and you're like, look, man, I'll make a lot of money. It's going to take me 30 years to pay back this $1,000. They would say, oh, you borrowed $1,000? Well, you're going to pay $5.369 one time. So your monthly payment is going to be $5.36. Well, guess what? If you borrowed $2,000, you'd be paying $5.36 2 times. Anybody got a calculator? I probably should have had a calculator ready, but you all can calculate with me. 5.369 times 2.
$10.73.8.
$10.73.8.
Yeah, 738. Yep.
Right? Because you paid $5 2 times. Because $2,000 is $1,000 plus $1,000. Well, if you borrowed $5,000, you'd be paying $5.36 5 times. So if I do 5 times 5.369, what do I get, Maria?
Let's see. 5.369 times 2684 26.845.
Now, I haven't done the problem yet, but does everybody in the chat give me a yes or a thumbs up? Does everybody understand that all of these numbers in the chart are a dollar amount that you pay for every 1,000 you borrow? If I have lost you, be like, no, I don't understand, Kandyce. Slow it back down, rewind, and I will talk about it again. Sweet. So now that we understand the chart is not scary, it's literally just a rate of payment. And guys, you buy books. If you all look at me and not my screen, but if you look at me, you see this? It's a book of amortization tables. Your banker is not a magician. They're not smarter than you. They have a book and they say, I look at your credit score and I think you're going to get 7% for 25 years. And get the number from the book. Cheater McGee's. So don't think they're smarter than you. Don't get overwhelmed by it. You just need to know, how much am I paying for every 1,000 I borrow? The better your credit, the better you're going to get a rate. So that's why the rates are so important when we talk about this. Well, now that we understand that, we know in the problem that she's going to pay, Kathy is paying this $5.36 for every 1,000 she borrowed. She's getting a $225,000 mortgage. So what I need to know is how many thousands are in 225,000. If you had a $1,000 bill, how many $1,000 bills would it take to get to 225,000? Well, just in case you're wondering, change it to a different color. If I've got 225,000 and I divide it by 1,000, even I can do this math without a calculator, bless my little heart. That's 225. There are 225 1,000s. So you're going to pay that $5.36 225 times. Anybody want to tell me what that is? When you take the $5.36.369, multiply it by 225, what do you get? What we discovered is your payment's going to be $1,208 a month. This is your amortized payment. You're going to pay $1,208 12 times a year for 30 years. You're really going to pay this 360 times. Would y'all do that math for me? If you pay every single penny, $1,208 for 30 years, 12 times a year, 360 times, what do you get as a total?
I got 434,880.
430 what? 4,000.
34,880.
That is the total principal and interest. All those checks that you write, all those drafts from your account, all of that adds up to $434,000, almost $435,000. Maria, do me a favor. How much did we borrow again?
225,000, right?
Yeah, we borrowed 225,000. That is your total
So
principal.
total interest paid. If they ask you what total interest did Carla, was it Carla or Kathy? I don't remember.
Carla, Kathy, I don't know.
Yeah. What is her total interest paid? Well, whatever isn't the principal, right? 209,880.
Yep. Total interest.
209,880 bucks. That is important because that could be another potential math question. They could ask you, okay, how much was her total interest? Well, remember, we just got to isolate the amount of principal paid, take it away from the total of all the payments, and what's left over is this big old whopping interest payment that we make to the bank for the privilege of renting their money, right?
Oh, so you're paying the bank almost $209,000 so you can borrow that $225,000 that day.
And what
So-
we picked a 5% interest rate, right? Right now it's going to be more like 8.
Oh,
So
here
what
you go.
do is we would say, I'm going to type it in the chat. So what we would do is we would take if they gave us the payment amount, we would divide that by the number from the chart.
The payment amount divided by the factor,
right? Which was
we get from the chart.
Right? Divided by the number from the chart equals whatever it is. And then you multiply that number times 1,000. That was the one I did. Now, what if instead they gave you, like the one Kandyce did, they gave you the loan amount. Now we got to figure out how many units of 1,000 we're dealing with there. Divided by 1,000 equals times whatever that is, times the number from the chart or the factor.
So maybe if you look at it this way, you'll notice that it goes together. You have a payment amount, right? Pick a different color. We have a factor, we have a factor. We have a loan amount, and I didn't finish it, but this is going to say in 2 shakes of a tail feather,
So
and we've got divided.
What they're asking you for. Shanika had a good question. No, the prepayment penalty shouldn't be that much. And usually a prepayment, remember the only ones that are allowed to have prepayment penalties are conventional and not all do because FHA and VA don't allow it. But if you do have a prepayment penalty, it's usually a couple points. It's not a whole lot.
So Sapna, I just want to make sure Do you see that it's actually the problem worked backwards? Does everybody see we actually did the same exact math? We just worked it backwards or round robin. You guys realize this is no different than me saying 6 times 3 is 18 and me going 18 divided by 3 equals 6 or 18 divided by 6 equals 3. It's all kind of the same math. It just depends, are you going right to left or left to right? So all the same. But hopefully this helped me. Give me an emoji. Y'all know how I feel about my emojis. Give me an emoji if this kind of cleared up this amortization table for you all and you're going to get to the test and not freak out. Yay, a lot less scary. Yay, I'm going to stop my share now. Yay, I love it.